In this video, we're going to be looking at the H1N1 data. And so we're going to start off with a little article about H1N1 from 2009. And this flu, the H1N1 flu, appeared in 2008, 2009. And so this data is from that time frame. So we start with reports of the swine flu began in southern Mexico on April 13, 2009. 8 days later, on April 21, in 2009, the U.S. confirms 2 cases, and the cases in Mexico are also confirmed as the actual swine flu. On April 25th, and so you can see that's like 12 days after the first cases, the World Health Organization declares this a public emergency, and there's an international effort to contain the spread. And so what we want to do is take a look at the data. So we have the data here, which is days 8 through 27, and we have a graph of that data as well. So in the first section of data, I see a distinctive concave up, and because of that, I'm thinking I want to use exponential. And then the rest of the data, there's the gap here from days 18 to 22, but the rest of the data really is in 2 clumps because there's such a big jump if we look in the data between day 24 and day 25. I don't see a distinct pattern in the remaining data, and so what I'm thinking is that I'm going to use linear for that remaining data because I don't see a distinct other function in it. So what I'm going to lead you through is going to your graphing calculator and putting in the data to create the piecewise defined function. So when I go to my graphing calculator, the first thing that I did is I put in the first group of data. So if I go to Stat and Edit, you see that I put in days 8 through 18, which is that first group of data. And what I want to do, we said that that had the concave up curve. So I want to do a exponential regression for that. So going back to Stat, over to Calculate, and down to EXP regression. I'll hit Enter enough times for this to run the regression and get me an equation. So now that I have a formula, I'm going to take that formula and I'm going to put it in the y equals part of my calculator so that I can see the formula and the data at the same time. So going into y equals, I have this formula typed here, and I set up my window. I went 30 days, so 0 to 30 and 0 to 3,000. And I did that because that's what was done on the graph that we looked at here. So we see the 30 days up to 3,000. And so just mimicking that graph that we had been shown. And I'll hit graph. And we see our data points here as the squares, and we see this exponential curve, and we see that that exponential curve really does fit our data. So what we know so far is that we have a curve. I'm going to write this down, y equals. I'm going to use the brace here. And for the first grouping of data, we have the equation 0.021 parenthesis 1.74 to the x power. And the data that we used for that was the data where the time was from 0 to 18, or you could start that at day 8 because that was truly our first piece of data. So now we have this rest of the data, and we need another piece, another function to model that. So I'm going to go to my calculator, and I'm actually going to go to Stat and to Enter to Edit. I'm going to put this in lists 3 and 4 so that we can see all of it at the same time on our calculator. You're welcome to do that too, but you also on your own calculator can put it in list 1 and 2 and just see each piece at one time. So I'm going to enter the data, entering the days in list 3. And then I'll go over, and in list 4, I'll enter the confirmed cases. one more. So there we have our data. So in order to see that data on the graph, I'm going to go into my y equals. I'm going to go up here to plot 2, hit enter, and then I'm going to hit second y equals to check on my stat plots. And I can see here that I do have plot 2 set up to show me list 3 and 4. So if I take a look at the graph, my first group of data is the blue data, and the exponential models it well. The exponential does not model the red data. So we see that the exponential is much steeper than where the red data fell. So the next thing we want to do is get an equation for that data that's represented in red, and we're going to do that by going to Stat, over to Calculate, and we had said we'll pick linear because we did not see a distinctive trend other than linear. And then I need to change this to work on list 3 and list 4. And I'll run that regression. And so we get an equation. And again, I would like to see how this equation matches up to our data points before I finish writing the piecewise defined function. So I'll type that in. And let's take a look at the graph. So we see that the red line does a reasonable job of capturing the data points that are in red as well. It does not perfectly get them, especially where we had the huge jump between day 24 and 25. So that data point on day 25 is just a little above our line, but the line does a reasonable job for the other data points. Now, we also notice that the red line would be a reasonable estimate of a couple of the points in our first data set, so it looks reasonably close to day 16, 17, and 18, but definitely does not capture before that. And so when we pick to set up our piecewise defined function, we want to limit where we use the blue piece versus where we use the red piece. So I'm going to go to my PowerPoint slide here, and I'm going to add to this that second equation that we got. So we have our second equation, which is 229.11x minus 3590.47. And I'm going to choose to use that starting day 19. And that was good through our data set, which went up to day 27. And so this is my piecewise defined function. Now, the H1N1 flu, part of why we have those two different trends is back in the article we read. So if I go back to this little blurb, this news blurb, we see that 12 days into this, the World Health Organization declares a public emergency and international efforts to contain the flu are implemented. And so whereas flu normally starts out spreading with an exponential, we see that those efforts just a few days in already had made a difference, and the second grouping of data did not follow the exponential, but starts a linear trend, which is what we have heard in the media as flattening the curve. And so instead of going almost straight up, the curve takes on a different angle. So this problem walked you through that process of creating a piecewise defined function where you're going to put in a smaller set of the data and create a function for that, and then put in the second set of data, which can be done in lists 3 and 4, or you can replace the data that you have in list 1 and 2 to get that second regression equation.